general relativity, step by step. Last time I talked about the weak energy condition, the WEC, and now I'm going to talk about a strengthening of that called the dominant energy condition, the DEC, which is a restriction on your stress energy tensor corresponding to observable and realistic, sensible kind of stress energy tensors. It's easy to get carried away with stress energy tensors and have all sorts of crazy things that don't correspond to anything real. I'm going to need some new notation, so I'm going to set up an x and a t coordinate system here. This is just flat Minkowski space, and I've got left and right light curves. I'm going to talk about a future pointing causal vector. Future pointing causal vector. Future pointing causal vector. And basically it's a vector that's inside the light cone. So it's not space-like, it's time-like inside there, and it's also not pointing backwards in time. So if U alpha is a future pointing causal vector, what does that mean? Well, that means two things. It means that U alpha has got to be less than or equal to 0. No, not equal to, it's got to be strict, because if it was equal to 0 it would be a light cone. And also U0 has got to be positive as well. So it's like the vector in the unit time direction. Those things there, future pointing causal vector. Now what's the dominant energy condition? The dominant energy condition states that if U alpha is a future pointing causal vector, then V beta, which equals minus T alpha beta U alpha, is also a future pointing causal vector. And that is the dominant energy condition. And I'm going to stop there, and I'm going to work out some of its properties or some of its consequences in the next screencast. Stop.